All right, hi everybody, it's me. So in this screencast, you're going to have a mini lesson, and then I'm going to have a problem set for you to do, and this will constitute homework for over the weekend. Okay, so the first part of this lesson is a review of exponents, negative exponents, and rational exponents. Sometimes people like to refer to rational exponents as they'll say like fraction exponents or fractional exponents, okay? So, and again, what you want to do is make sure you take good notes, pause when you need to catch up, and let's get started. All right, so we know, I mean, this should all be old news. We know that 3 squared equals 9. We also know that negative exponents, 3 to the negative second, is equal to 1 over 3 squared or 1/3 the second. So a lot of people just forget that when you've got a negative exponent, what you can do is you can either choose to reciprocate the base, okay? So reciprocate the base, which means 3 is the same thing as 3 over 1. You can write 3 over 1 as 1/3 and then make the exponent positive. Or you can go ahead and take 3 and move, bring it down to the denominator, so to speak, and write that as 1 over 3 squared. It's up to you, but I know that in some cases, this method is advantageous, and in others, this one is, like the idea of just reciprocating the base of the exponent. In either case, it equals 1/9. It's more to the point here. Like, look at 2/3 to the negative third, okay? 2/3 to the negative third, I could have gone this route. I could have said, well, this is the same thing as 1 over 2/3 cubed, right? Bring the entire base down to the denominator, right? And then cube it. And then this would be 1 over, okay, 2 cubed is 8 over 27, which then equals 27/8. But here in this case, I would opt to just say, well, let's just take this base. The base is that which is being raised to the exponent, and let's just reciprocate that, right? Make it 3/2, and then just make the exponent positive this way. And that gives you then 27 over 8, okay? Things get even a little more tricky if you look at things like this. Let's say I've got 6 over 2 to the negative third, right? So here, be careful, 6 is not being raised to any power, and here I have 2 to the negative third, 2 to the negative third, so 2 is being raised to a negative exponent, but it's in the denominator. This is equal to 6 times 2 to the positive third, right? So a negative exponent in a denominator, you can write that with a positive exponent after I bring this number up, so to speak. And of course, it's an unwritten but understood 1 in the denominator, and this becomes 48. Okay, a couple more examples of this. Let's just do another example before I move forward. How about this one, everyone? Let's see, 7/2 to the negative second. Okay, go ahead and what would you do here? I would probably, again, go ahead and do this, 2/7 squared, and make this 4 for 49. Okay? All right, continuing with exponents. The next thing I want to say to you is that we know that the square root of 25 equals 5. We have traditionally seen square root written this way, but the square root of 25 can also be written as 25 raised to the power of 1/2. So look at that. Here we have a fraction or a rational exponent, 25 to the 1/2. This 1/2, right, something raised to the half means the second root or the square root. Okay, similarly here, we know that the cube root of 64 is 4. I could write the cube root of 64 as 64 raised to the 1/3, right? And so this power of 1/3 means the third root or the cube root. And then we can do some pretty funky things. First, just let's have a general rule. When we see a number a raised to the power of 1 over n, this means the same thing as the nth root of a. And then we can pull it all together. So what about 64 to the, now look what we've got here, negative 1/2. 64 to the negative 1/2. Well, maybe I would choose to go this route and say, well, 64 to the negative 1/2 equals 1 over 64 to the half, right? Or I could reciprocate 64 and make it 1/64 to the half. Either one of these is correct. And then 64 to the 1/2 means the second root of 64, the square root of 64, which is then 1/8. And then we can do some really wild things like this. Negative 8/27 to the negative 2/3. So first, a little bit of a blast from the past. You have to remember, so recall back in the day, if you had b to the third and then to the second, I think you may have called this rule like the power to a power rule. The result here is b to the 6th. You multiply the exponents, but it's power to a power. So I want to show you something. Negative 8/27 to the negative 2/3, like that's alarming, right? Well, we can also write it this way. We can rewrite this as negative 8/27 all to the 1/3 and then to the power of negative 2, because look what happens here. A power to a power, the power of 1/3, to a power of negative 2, if I apply this rule of exponents, 1/3 times negative 2 does equal negative 2/3. So this rewrite right here is 100% valid. It is equivalent to the original exponent of negative 2/3. And let's see, what did I do here? That is, what did I do? Oops, okay, I went a different direction. Okay, so now I'm going to say, okay, what is negative 8/27 to the 1/3? This is asking you for the cube root of negative 8. Well, that's negative 2. What's the cube root of 27? Well, that is 3. And then we have to raise, so here I've taken care of the cube root. Now I want to raise this to the negative 2nd. And maybe here you'll say, you know what, I'm just going to feel like reciprocating the base and raise it to the positive 2nd. And what I get then as a final result is 9/4. Okay? And then if you look over here, you'll see I went about it a different way. So here I took this question and I rewrote it. What did I do, everyone? I took the original base and I reciprocated that, and then I made the exponent positive. But then I kind of used that property again right here, right? And then I just took it all the way through. As you can see, same result. So I'm just showing you, this might be new to you. It may be new, but you saw it last year just quickly. But we're working here with fractional exponents, negative exponents, and maybe a little bit of properties of exponents too, okay? What do you think about this one? 9 to the negative 5/2. 9 to the negative 5/2. Well, I should make the choice here to rewrite that as 1/9 to the 5/2. Okay, 1/9 to the 5/2. Maybe you wanted to go this route and said, okay, let's do 9 to the 1/2 to the negative 5. You could have gone in either direction. At the end of the day, we'll get the same answer. But 1/9 to the 5/2, okay, well, power of 5/2 is the same thing as a power of 1/2 to the power of 5. 9 to the 1/2 is 1/3. 1/3, all of that to the 5th is 1 2/43. Let's see. If we go this way, 9 to the 1/2 is 3. 3 to the negative 5th is the same thing as 1 over 3 to the 5th, which equals 1 over 243. Okay, so this screencast is just about exponents again, working with some negative exponents. What we're going to do is I'll end it right here, and then I'm going to post some questions that involve evaluating with this, with these kind of negative exponents and rational exponents. Okay, goodbye.